So, if you can see this, yes, the moment distribution will require you to calculate the fixed moment before anything. So when you have a settlement, that means it's unlike the slope deflection where you can put your delta into the equation, right? But we do have the formula to calculate the moment due to settlement as well. And if you have this sheet, you should be able to see this equation. So that's exactly what it is. If you know the settlement from the beginning, you can put it in this equation and be mindful of the direction as well. Okay. I didn't do quite a good job in here because in this picture, you should have it as a negative value because, if this becomes a clockwise joint displacement, the resisting moment should be counterclockwise. So let me try to write again on the iPad. Oh, here we go again. Doesn't seem to go well. Let's do it one more time. Doesn't seem to go well at all. Let me try one more time. Okay, at last. All right. So you see when you have the settlement. Okay, so let me focus on the settlement alone, right? If your member comes down like this, so you see the whole picture is that your member is now moving in the clockwise direction. So you should have counterclockwise moment to resist it. Okay, and in this case, if you know the settlement, your Mij is simply equal to minus 6 EI delta over L squared. And that will be the value that you can begin with. Okay. And I can have the example to show you next time, but it's just nothing more than just begin with another value from this formula. Okay, so it's really no big deal. And please, everyone, if you have more than one loading conditions, superposition works. Okay, believe in that. All right. So now let's go back to our business. You see, from the previous example, again, we have the issue with our simple end support, right? In this case, if you look back at your example, maybe I should, this one, this is a simple end. So you know that the sigma moment, or MD, must be 0 in the end. And we haven't done anything, apart from, giving the same number of moment over and over again, just to make sure that in the end it comes out 0. So it seems a bit, not very efficient to do it this way. So yes, we can do something about it, just like in slope deflection. If we can have the special equation, the modified equation, to help reduce the work when we have the simple end support, surely we can do the same with the moment distribution. All right. So without further ado, let's do that. Okay. Now, this time, oops. You know, in the beginning, we have this, right? And we say this rotate. So I will see how things go. But this time, let me say that we have this end instead of that. Okay? And we have rotation here. And I can do the same. If this is my joint I, this is my joint J, and the rotation take us to look at something like that. I can now write my Mij. It's 2 EI over L, 2 zeta I, J. Or I can just say I is fine, right? Plus zeta J minus 3 psi plus fixed end moment. But this is 0, right? We don't care about that. And then Mji is 2 EI over L. Oh, it's like my handwriting becomes really bad now. I'll try to do better. 2 EI over L, 2 zeta J plus zeta I. Okay, I'm going to spare the psi and the fixed moment. But again, we know that Mji is 0 for sure. So we can solve this, by using these two equations. We can realize that zeta J is equal to minus zeta I over 2. Okay? So I can bring this back into this equation. So Mij, when I plug that in, I will have the term comes down to 3 EI zeta I over L. Now, remember in the beginning that if you have the typical situation like that, your Mij is equal to 4 EI over L zeta I. The difference is that when this n is changed from fixed to something of a simple n where moment is 0, if you compare these two structures, let's say they have the same moment of inertia. This one is weaker, correct? Because another end is a roller. So it's weaker. It's easier to bend. You can bend it more easily, and under the same amount of moment, it should deflect more because this makes it weaker. And so Mij becomes 3 EI over L instead of 4. So when you make a comparison between the case with the fixed and the case with the hinge, this one, the fixed, has a stiffness of 4 EI over L. This is the stiffness of the fixed. But when you have a roller, your stiffness becomes 3 EI over L. Simple N. So let's say if this is my new K, I can say my new K, let's call it Km over K original Ij is 3 over 4. So Km is 3/4 of your original Kij. So you can say whenever you change the support into a simple n, from fixed to simple n, your member is only 75% as strong as the original one. And this becomes your modification. Okay? So I have one of the two choices. I can go back to the example that we just did, or I could just leave that to you and show it to you and show you the next one. And I think I will do the latter so that you see more examples. Okay. So let's move on to the next example where you have this. Oops. Six, seven, okay. And you have a point load here, 5 tons, and you have the uniform load here. Wow, what a good accident! 40.5 ton per meter. Okay, and I believe the span length is 6 meters. 7.5 here, and 4.5 here. Okay, the I is constant. All right, so let's focus on the relative stiffness first. Okay, now you should know that I'm going to call this A, B, C, D, right? All right, so step number 1. Relative stiffness. Okay, this time your K AB is I over 6. K BC is I over 7.5, and K CD is I over 4.5, right? So I'm going to use the the least common number of 90. So this becomes 15K. 90. This becomes 12K. And this becomes 20K. Okay, now take a breath and see, do we have simple n conditions? Yes, we do. Support A and support D are simple n supports where we know moment are 0 for sure. So there's no point trying to work support A and support D. So when you have this case, it means that you can modify the stiffness of the members associated with the simple end. In this case, it's member AB and member CD. And we now know that our modification is 0.75. Member AB will be only 75% as strong when you compare to the case where support A is fixed when you compare with this. Okay, so let's erase that to reduce confusion. Okay, so 5 times is gone as well. So that means I can further modify KAB and KCD. So we modify with 0.75. We multiply this with 0.75 to recognize the fact that this is the member where it is at the end of the structure and the end support is simple support. So this K becomes 11.25 K, and this one becomes 15 K. Okay, we modify it so that we have the new K. So that means when I calculate my distribution factors, I am going to use this new one. Okay, so DF of member AB, I'm sorry, it should be BA, right? Is 11.25 over the sigma KB, which is equal to 11.25 plus 12 now, which is 23.25. So this turns out to be 0.48. And next is the distribution factor of BC. So that is 12 over 23.25. That is 0.52. Notice that still remains 1, right? And the next is for joint C. So I can write it down here that my sigma KC is equal to 12 plus 15. That's 27. So my distribution factor CB is now 12 over 27. That is 0.44. And for member CD, that's 15 over 27. That's 0.56. Okay. And let's make a quick work on fixed moment. That's a long one. So FEMAB, that's equal to minus P AB square over L square, that is minus P is 5, A is 1.5, B is 4.5 square. Don't get your formula wrong, okay? L is 6 square. Some still can, do it incorrectly here. So this is minus 4.22 ton meter. And FEMB BA, that is PA square B over L square, that is 1.5 square 4.5 divided by 6 square. Okay, so that is 1.41 ton meter. The last one is FEMBC, right? That is minus WL square over 12, which is minus W is 4.5, L is 7.5, square over 12, that is minus 21.09, which is equal to, that's 21, it's equal to minus FEMCB. So we are now ready. We have only a few minutes left, but we should be able to take care of our business, okay? So let me try to begin by drawing beam, of course. Okay, all right. This is 0.48. Maybe I should draw it here. Give me some more space. 0.48. Oh, it's very difficult to see. Let me erase that. Okay. And try to grab that. 0.48 and 0.52. Here is 0.44 and 0.56. Now, what about your simple n? Remember, we have modified our structure already, so you should not bother with it anymore. So this should be equal to 1, as if it was fixed. And this should be 1 as well. Okay? And now you can start your distribution. Okay? And now your unbalanced moment is minus 4.22. This is 1.41. This is minus 21.09 and 21.09. Okay. Well, I didn't do it the shortest possible way. So I don't have the number, the final numbers for you. You can do it yourself. But what you should begin is this. You see, this is a simple n where you do the modification already, and this too. So whatever you do, you will never carry the moment back to them, because this is over and done with. And it is a simple n, and the moment must always be 0. So we don't carry the moment back there. Okay, but when you begin in the beginning, when you have the unbalanced moment, you should try to balance that first. Okay, without doing anything, and then, you know, carry this over. So it's 2.11. Okay, so that, you know, when you try to balance this from the beginning, this is already out of your equation. Okay, so when you balance this, you can carry this over at the very beginning, so that when you try to balance the first one, it's this one as a total moment. Okay, I don't remember the color that I should use anymore, but you know, in the end, so we have 1.41 plus 2.11 minus 21.09. So you need minus 17.57 for that. So that means your balance moment will be equal to 17.57 multiplied by 0.48 on the left. This is equal to 8.434, and on the right it's 9.136. So, you know, if you pay that means this whole cycle, this is the end of your first cycle. Okay, and the sigma moment here should be equal to 0. All right, and for support C, that's minus 9.28, and this is equal to minus 11.8. So now you can say that's the end of your first cycle. Okay, and the next one is the important one, because it just goes to show that when you modify after modification, this will not be carried over. Okay, you're done with that. Okay, so you would have the carryover from this and from that. Okay, this is minus 4.64, and that is 4.57. And then you would balance just the moment at support B and C without ever going back to A and D. So this helps reduce the work. All right, so you know this 4.64, you need that multiplied by 0.48, so that's 2.23, and then that's 2.41, and that's minus 4.57 multiplied by 0.44. So this is minus the 2.01 and minus 2.56. and then you would carry on with just these two. Okay. And I think that should be enough, because you would be able to carry this out for yourself. Okay. And, in the same fashion. Okay. So is there any question? Oh, I should after the cycle. That's the end of the second cycle. Okay. You should carry on until the moment becomes less than 3%. But of course, it should convert faster when you're dealing with just the two supports. Question, please. So there isn't any question then. So let me stop the share and stop the